All right, now we're ready for our next lesson. And this is going to take our factoring kind of to the next level. In all the problems we've done so far, it's always been just x squared as our first term. There's always been that 1 there that we didn't have to really worry about because 1 times 1 is 1. But now we're going to start to have a coefficient in front of that x squared term. So that means now I not only have to worry about what the second term in each answer is. Before I had to find that second number and whether it was positive or negative, but now I also have to worry about, is there a coefficient on the x term that goes with it? So we're going to use a lot of the same pieces that we've done before and a lot of the same steps. We're just going to put them together in a slightly different way to help us tackle both of those pieces. All right, so first things first, we always look to see if there's a greatest common factor that we can factor out. Doing that helps keep my numbers smaller, keeps them more manageable, and I'm more likely to be able to find what I need to multiply or what I need to add because I'm working with some smaller numbers. The one change for these problems that's different from the earlier factoring is instead of just worrying about how do I get C, I now have to also worry about how do I get A. So something got multiplied to get 2, something also got multiplied to get 18. So this time I'm going to multiply A and C together. So 2 times 18, and I'm going to get 36. Now I'm going to focus on, okay, what could I multiply to get 36 that I could use to find my 15? So I want to get 36, but I want them to add to be 15. Well, I could do 1 times 36, I could do 2 times 18, I could do 3 times 12, I could do 4 times 9, or I could do 6 times 6. Well, if I want it to give me 15, I'm going to have to use my 3 and my 12. In this problem, it's plus and plus. So I know my answer is going to be plus and plus here. I know I want to have a 3 and a 12 in there in order to get to my 15 in the middle. But the problem is I don't know where the 12 came from. Because if you think about it, I'm going to multiply this first term here, and then I'm also going to multiply it here. So that could be a 1 and a 12. It could be a 2 and a 6. So now that I know that I have to worry about that first coefficient, I can't assume the 12 is automatically just my number in the problem. So this is where we have to do a little bit more work here. Okay? So follow with me as I kind of set this one up. I know that once I get my answer, once I get my solution, if I were to multiply them out, I'm going to get 2x squared as my first term. I know I'm going to get 18 as my last term. And I know I'm going to get a 3x and a 12x in the middle, because together they have to add up to be my 15x. So this time, instead of just taking the 3 and 12 and throwing into my answer, I'm plugging it back into my problem because I have to figure out, okay, which numbers go where to get to a 12 and to get to a 3. So here's the strategy we're going to take. We're going to factor this new problem in parts. So for instance, I'm going to factor out the first 2 terms. What can come out of 2x squared and 3x? Well, I can factor out an x out of each of those, and I get 2x plus 3. Now I'm going to do the same thing with 12x plus 3. What could I factor out of both the 12x and an 18? Well, I can factor out a 6, and I'm left with 2x plus 3. That's what we want. We want to factor both halves of the problem, leaving us with 2x plus 3. That's going to be one of my pieces. The pieces that I factored out, the x plus 6, that makes my other binomial. So I figure out what those middle numbers have to be. I write it out like it would have been if I had multiplied out all the pieces, factor each half of it, and that gives me the pieces that I need to put together my whole answer. If I were to go ahead and multiply x plus 6 times 2x plus 3, I would get 2x squared plus 15x plus 18. Okay? Now, I know it seems like a lot of steps, so let's see this in action a couple more times, and I think you'll start to get the hang of it. All right, so 2x squared minus 3x minus 2. First things first, is there anything I could factor out of all three terms? In this case, no. So I got to go ahead and try to factor it out using my new method. So I have a minus, minus. That means I'm going to have opposite sides, a plus and a minus. Then I'm going to figure out what my AC is equal to. Well, 2 times 2 is 4. So I want them to multiply to give me 4, but I want them to subtract to give me 3. Because they had different signs, we know it was going to be subtracting in the middle. Well, to get 4, I can either do 1 times 4 or I can do 2 times 2. The only one that's going to give me a 3 for a difference is if I use a 1 and a 4. So same steps we did in the earlier kind of problems. But now I can't just go and plug the 1 and 4 into my problem yet, because I'm not sure where the pieces are going to go. So this is where I have to do kind of that intermediate step. I know I'm still going to have 2x squared at the beginning and minus 2 at the end. But now I want to see what are the two pieces I was going to have to get a negative 3 in the middle. Well, one's a plus and one's a minus. So let's do plus 1 and minus 4. Those are the only ways that when I combine them together, I get negative 3 in the middle. All right, next step. Kind of think of it as 2 halves. I'm going to factor each one of them by itself. So 2x squared and 1x. What could I factor out of both of them? Well, they both have an x in common. And if I took an x out, I would be left with 2x plus 1. Now, what does negative 4x and negative 2 have in common? Well, they both have a negative 2. So if I divide a negative 2 out of each of them, negative 4 divided by negative 2 is 2x. Negative 2 divided by negative 2 is 1. And this is what we always want to happen. We want what's left over to be the same for each of them. 2x plus 1. Then the pieces that I factored out of each of those parts, my x and my minus 2, that forms my second binomial. So I try to figure out, okay, what are those two middle terms going to be? I factor it by grouping. I kind of factor the first half and I factor the second half. And when I put those pieces together, it gives me the solution that I needed for that problem. All right, next one. 3m squared minus 8m minus 3. Well, 3, 8, and 3 don't have anything in common, so I can't factor anything out. So I start with AC. A times C is 9. So I want to multiply things that are equal to, going to give me 9. When I look at my signs, I have a minus and a minus. Remember, anytime your last term is subtracting, we know we're going to have opposite signs. So in this case, my B is 8. But because they have different signs, I know I had to subtract to get 8, not add to get 8. So what could I multiply to get 9? Well, I could do 1 times 9, or I could do 3 times 3. But which one is going to give me 8 as a difference? Well, the only one that's going to work is my 1 and my 9. So I know I have to use that combination. All right, so now I try to show my multiplied out version of my problem. So I know the first term is always going to be 3m squared. I know my last term is always going to be 3. But now I know that I have a plus term and a minus term in the middle that combined to give me negative 8m. Well, I have a 1 and a 9. I want them to combine to be a negative 8. So I need a positive 1m and a minus 9m. Okay? And it doesn't matter which one you list first as long as we put the plus and minus with the appropriate term. All right. So now look at each piece one at a time. What could I factor out of 3m squared and 1m? Well, they both have an m in common. So I'm left with 3m plus 1. What does negative 9m and negative 3 have in common? Well, they both have a negative 3, and I'm left with 3m plus 1. All right, so I know my positive term is the 3m plus 1. For my other one, I have m minus 3, so m minus 3. Those are my two pieces for us. All right, hopefully starting to make a little bit more sense to kind of get in the flow of the problem.